Okay, this video is going to have sound in it. There are a couple mistakes that I need you to fix, and then I'm going to have you write a few problems on paper to turn in to prove to me that you did watch this. So here we go. First problem, first ratio problem. You are comparing the first number 14 tetras to 21 guppies. So 14 to 21, that first number listed is going to go right on top, compared to that second number is going to be on the bottom. I'm going to divide both top and bottom by 7, so I'm going to reduce that down. So when I divide top by 7 and the bottom by 7, I should get 2/3. So that is the reduced form, 2 tetras to 3 guppies. That is the ratio. For number 2, for this one, you need to find the numbers from the bar graph to put this into the ratio form. So this one's asking for blueberries to people who like oranges. So the blueberry number first to orange number second. So if I look on my bar graph, blueberries, if I look over, it shows me it's 40. So that number goes on top. For oranges, if I look in the orange bar, it goes all the way up, and I look over at 30. So those are where I'm getting my numbers. So 40 for blueberries and 30 for oranges. When I reduce that down, I could either slash off those zeros and make that 4 to 3 or 4/3, or I could divide top and bottom by 10 to get 4/3. Alright, the first problem I'd like you to do to prove to me that you have watched this and get a similar answer to 4/3, I would like you, for number 1, from this table, or I'm sorry, from this bar graph, what is the ratio of kiwi fruit, which is 25? What's the ratio of kiwi fruit to blueberry? So again, first problem on the paper to prove to me that you've watched this is, what is the ratio of people who like kiwi fruit to people who like blueberry? I want to know that ratio. So 25 to 40. Alright, let's keep going. Problem number 3. For this, it's having you compare the ratio of grape to the total of the juice boxes. So on this, find the grape number. That number is going to go on top over the total number of juice boxes. So 5 plus 10 plus 5. That total goes on the bottom. So 5 to the total number of juice boxes. So 5 on top, 5 plus 10 plus 5 gives me 20 on the bottom. So that ratio is 5 to 20, which reduces down when I divide both top and bottom by 5, which you can do. 5 divided by 5 gives me 1 on top. 20 divided by 5 gives me 4 on the bottom. So that ratio is 1 to 4. 1 grape juice box to 4 total juice boxes. Alright, table problem. This wants the ratio of soccer players. So that first number asked for is the number that goes on top. Soccer players, 30. 2, that's my fraction. Volleyball and baseball. So I'm going to combine those two numbers for that denominator number. So 30 is from my soccer players. 2 is my division line. The total of volleyball and baseball, I take these two numbers and I add them up. 30 plus 20, that gives me 50. That is my bottom number for this ratio. For this, I again could slash off these zeros, or I could divide top and bottom by 10 to get that ratio of 3 to 5. Or, again, divide both top and bottom by 10 to get that same ratio of 3 to 5. Alright, here comes problem number 2. For the second problem on a piece of paper to prove to me that you've watched this, I want the ratio of volleyball players to soccer and baseball. So for problem number 2 on that piece of paper that you're going to prove to me that you've watched this video, I want you to compare the ratio of volleyball players to soccer and baseball. Alright, here we go, number 5. Alright, this one has you find the total and then use that number or use the number that you're adding to get that last unknown number. I see these are going up by 2, but I'm not going to worry about my rocks. I'm going to focus right here on my shells. So if I could see how much this is going up by, and if I can make sure that's the right amount, I'm just going to take that 64 and add that to get that missing number. So if I subtract a couple here, I see that 32 minus 16 is 16. And if I take that total of 48 minus 32, I also get 16, which proves to me I'm adding by 16 each time. All I need to do is take that 64 and add 16, and I will get that missing number. So 64 plus 16, if I add that up, gives me 80. That is the number. Alright, for problem number 3, here it is, problem 3 on that piece of paper. I want you, using this table, I want you to tell me what is the ratio of shells to rocks. So what is the ratio, the shells to rocks? So you could use any set of numbers here, 16 over 2, or compare 32 to 4. So again, problem number 3 on that piece of paper that you're going to use to prove to me that you're watching this. I want the ratio of shells to rocks in reduced form. Alright, here we go. Number 6. Problem 6, some math terms. Just remember, of this, that 8y is excuse me, a term. That negative 8 in front is a coefficient. That negative 8y piece all together, that 8y, is a term. It is made up of a product of negative 8 times y. So again, what this question is asking for, it's not a factor, it's not a sum, I'm not adding right there, it's not a coefficient, it's not a number in front of a variable, that is a term. Alright, question number 4 is, for this term, negative 8y, for that term, what number is the coefficient? What number is in front of y? And again, you got to make sure if it's positive or negative, you got to include that in there. So what is the coefficient of this term right here? That is question number 4. Alright, problem 7. 7 has you read the problem and match. So this is a sum of 2 products where the first term has a coefficient of 8. You know right away, if you look at any number with a coefficient of 8, there is only one choice that has a coefficient of 8 out of all those numbers right there. So you could right away probably answer this problem by just looking for this coefficient. What number coefficient? There's an 8 right there, there's a 5. Those are not coefficients in the first term, so those aren't going to work. So this is the only one that has a coefficient of 8. So that alone would let me know that that is the only choice. But to make it match, this has a coefficient of 8, and it's also made up of a sum, that plus right there, of 2 products. This is a product. 8 times x, that's a product. 5 times y, that's a product. This is a sum of these 2 products. This has a coefficient of 8. This one right here is a sum of 2 products where the first term has a coefficient of 5. So that would be a good question right there. So let's do that for question number 5 on that piece of paper that you're going to use to prove to me. Is for problem D, what is the coefficient of that first term for problem D right there? Alright, that's going to be your 5th problem. Alright, let's keep going. Problem number 8. And of course that one right there is C. Alright, problem 8. This one has you take and distribute. So if I take that 5 and I distribute, I know I'm distributing there because there's nothing between that 5 and parentheses. 5 times x, that's where I get 5x. That same 5 all the way down here times 7, that's where I get 35. So 5 times x, 5x, 5 times 7, 35. That's why this one has to be C. 5 times x, 5x, 5 times 7 is 35. So 5x plus 35. That is the equivalent expression. Alright, for problem number 9, for this one, to find that number that you're going to distribute, if you take that first and second number and divide those, you'll find that number out right away. So if you take 12 divided by 2, that gives you 6. It has to be 6. Because if you take that 6 times 2x, that gives you 12x. You could always check this by dividing the other set of numbers and checking. And again, if I take that second set of numbers, 60 and 10, if I divide that, I see that that gives me 6 also. So I know that's going to be true if both those numbers are 6. But again, 6 times 2x, 12x. 6 times 10 gives me 60. That's why that number has to be 6. 6 is the only number that's going to work because 6 times 2x is 12x and 6 times 10 is 60. Alright, problem number 10. For this one, my key is to first look for the problem that looks like distribute. In the distribute property, when you have a number out front of parentheses with 2 or more things being added or subtracted, so look for that. None of these other ones have that distributive property look. And then once you can lock onto that, distribute it. Take that 7 times a, take that 7 times 5 to see that the other equivalent expression has to be 7a plus 35. So that one would be 1 and 3. Make sure on this problem you give me both answers on this one. Any problem they're asking for more than one answer, just make sure you answer for both. Alright, next problem 11. This word problem is saying a small boat costs $13. They're going to use the letter S, which makes sense. And a big boat, a large boat, costs $21. They're going to use L. So those two letters represent those kind of boats. So S for small, L for large. $13 per day means I'm going to times that variable. So 13 times S I write as 13S. $13 each day. Plus that 21 times L. Because that's $21 per day. So if I take that expression and add that up, that gives me how much I'm going to pay. $13 per S plus $21 per big boat. So what I'm going to do here, and you can see that answer has to be D. I'm going to give you problem 6. And problem 6, I'm going to change this up and I want you to write the expression that matches what I'm saying. So we're going to say a student goes to a place that rents boats for $17 per day for a small boat, $17 per day. And they also charge $20 for a large boat. So write the expression of a place where you go and rent boats for $17 a day for a small boat and $20 per day for a large boat. Write that expression. That is problem number 6. That's going to go on that paper that proves to me that you've watched this. Alright, here we go. Problem number 12. This one has you take that fraction and evaluate it to the third power, which means I'm taking that fraction and timesing itself 3 times. So I take that fraction 1/4 and I write it out 3 times. 1, 2, 3. I'm not adding these, I'm timesing. So I'm going to multiply straight across both top and bottom. 1 times 1 times 1 is 1. Anything times 1 is 1. 4 times 4 times 4. 4 times 4 is 16. Times 1 more 4 gives me 64. So that is 1 over 64. Alright, for 13, for this one, first thing they want you to do is evaluate these exponents. So know that 4 to the second power is never 8. That is 4 times 4 is 16. 2 to the fourth power, don't worry about that negative, just worry about the base and the power. That is 2 times 2 times 2 times 2. So again, 4 to the second power, 4 times 4 is 16. 2 to the fourth, not looking at that negative, just focusing on this. 2 times 2 times 2 times 2 is 8. I'm sorry, 4 times 2, and then 8 times 2, and that gives you 16. So this one, evaluate the exponents first and leave everything else alone. And you could see right there in just that step, you could already choose one of your good choices here. And again, this is another problem where you need to choose more than one to get this right. So again, 4 squared, 4 times 4 is 16. 2 to the fourth is also 16, multiplying 4 of those 2's. I left everything else alone. So that is my first choice right there, which is C. My next step on this problem is to take that and distribute it. So I'm going to take that 2 times 16 and 2 times 7. So 2 times 16 gives me 32. 2 times 7 gives me 14. Remember, you have a calculator to use. So 16 times 2, 32, plus 2 times 7 is 14. Gives me 32 plus 14 minus 16. So you could see right there when you stop and look, that is the second choice. Make sure you pick both on those to get those correct. All right, problem 14. This one. 2 expressions that we want you to write out, spell out, kind of draw a diagram for to show that they are not equivalent. Never can you combine unlike terms. So to show this, I'm going to have you write out 7 squares to represent the 7 t variables. So I'm going to write out 7 squares where a variable means I could put any number I want in there. That's a variable. So 7 of those t's. And again, I don't know what t is, but I know there's 7 of those, and 7 of those right next to each other I write and combine as 7t. So 7 of those t's added up is equivalent or the same as 7 times t. Know that. So again, I could plug in any number I want for t, like 10, and get 70. All right, my next expression 2, I have 4 of those variable t's. So 1, 2, 3, 4. And again, since there's 4 of those, I could also write that as 4 times t. Plus 3 plain numbers here without a variable, so they're just plain numbers. I used to use red circles for that. I'm going to write that as 4t plus 3. So 4 of those t's combined together give me 4t. 3 just plain numbers combined to give me 3. And you can see this diagram shows you this is no way they're the same. If I was to plug in 10 for t, this would be 70. 7 times 10 is 70. If I was to plug in 10 right here, I would get 40 plus 3 is 43. That is not the same number. So for number 7 on your paper, to prove to me that you're watching this, I want you to take these 2 expressions, 7t and 4t plus 3. I want you to plug in a number for me in times and show me those are not equal. So I'm going to have you plug in for t, I'm going to have you plug in the number 5. So I want you to plug in a 5 right here and times by 7, and then plug in a 5 right here and times that by 4, and then take that answer and add 3. That is going to be problem 7 on that paper that you're going to turn in and prove to me that you've been watching this. All right, hardest problem on the test, 15. Here it comes. For this one, first thing I want you to do to solve for these missing spots on this table, if I could go back to it. Sorry about that. Right here. Again, to find those missing numbers here, I'm going to use a ratio. I could also, as you can see, list it out step by step, 1 through 10 if I want to see what those numbers are also. A couple ways you could do it, but I need you to know how to solve those missing numbers, setting up a ratio to equal fractions. So for that first one, part A, fill out the table. So to find this unknown variable right here, I'm going to use this square right here to use those numbers to set up the fraction ratios to make my life easy. So when I use this and plug in A, so I'm going to use the unknown variable A here. I'm going to set that up as 15 over A equal to 10 over 20. I'm going to set up just how it's written right there, how it looks. So 15 over A equal to 10 over 20. That is my two equal fractions, my ratio. So now I'm going to take that and I'm going to crisscross multiply. 10 times A gives me 10A. 15 times 20 gives me 300. And then I'm going to divide, so 15 times 20 gives me 300 using my calculator. And then to solve for A, the opposite of multiplying by 10 is dividing both sides by 10. So I divide this side by 10 and divide my right side by 10. And that gives me A, 30 on top. 30, use that calculator, top number first, divided by the bottom number second. Always type that top number first on your calculator, bottom number second when you're dividing. So that 30 goes right here. My next number in the table is this blank right here. So I'm going to shift down and now use this square right here. So those four numbers, that 75 and that 50 and that 70, to set the fractions up exactly how it looks in the table. So I'm going to have 75 here, and again, that is a 1, but that really is a 7, so if you could change that right away to be 75. So that's 75 over A equal to 50 over 70. So when I time straight across, 50 times A gives me 50A. 70 times 75, because again, remember that really is 75 right there. 70 times 75 gives me 5,250. And if I divide that by 50 on my calculator, I get that unknown number. Which is 105. So that 105 goes right here in that blank spot. All right, my last fraction. Again, to find this unknown, I'm going to take these two and set this whole little square up as a fraction. So I'm going to do 105 over 35 equal to 70 over A. So when I set this up, it becomes 105 over 35 equal to 70 over A. So when I crisscross multiply, this gives me 105A equal to whatever 135 times 70 is on my calculator, which is a big number, 9,450. When I do the opposite of timesing by 105, I divide both sides by 105. That gives me A equals 90. So that number goes right here. Alright, so that's part A, filling out the table. Now for part B, I'm going to extend this table out and do two separate conversions here. So this, I believe, is the hardest problem on the test right here. So for part B, I'm going to use two separate conversions. I'm going to use the first conversion of how many ounces in a pound. I'm going to use, for this conversion right here, I'm going to use 1 pound equal to 16 ounces. So if I set that up as a ratio, 1 pound to 16 ounces, that would be 1 pound on top to my fraction, 16 ounces on the bottom. 1 pound to 16 ounces. 1 pound equals 16 ounces. 1 to 16, that's the ratio of pound ounces. I'm going to use that unit. And for the pound bags, if she's buying it in 5-pound bags, I'm going to use the conversion of 1 bag that she's buying is equal to 5 pounds. So that's the ratio 1 to 5. So 1 bag to 5 pounds. That is going to be the second conversion I'm going to use. 1 to 5. 1 bag to 5 pounds. Alright, so now what I need to do is find out how much brown sugar and white sugar at the 10th batch, the 10th step right here. So I'm going to show you how to find that 10th step by listing it out, which of course you could use to fill out the table as well. So to list it out, showing what's happening between each batch, I'm going to list out all the batches 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 batches. That's the number I'm looking for. So for brown sugar here, I start with 15. I know there's 15 ounces for 1 batch of brown sugar. And then I'm going to use white sugar, and that starts with 10 ounces. So for brown sugar, starting with 15, and white sugar starting with 10, and using the numbers I got by filling out my table, I know the next step is 30, and this is 20. Now I have enough to find the pattern and fill out the rest of the table here. So I need to look and see from here to here, how much is it going up by? From here to here, how much is it going up by? And I can see that for my white sugar, it's going up by 10. For my brown sugar, it's going up by 15. So I'm going to keep following this pattern to fill out my numbers. So I'm going to take that 30 and I'm going to add a 15 to it. And I'm going to keep adding a 15, keep adding a 15. 30 plus 15 is 45. 45 plus 15 is 60. 60 plus 15, 75. 75 plus 15 is 90. 90 plus 15 is 105. 105 plus 15 is 120. 120 plus 15 is 135. 135 plus 15 is the number I'm looking for, 150. For white sugar, I'm going up by 10. So this is 10, 30, 40, going up by 10, 50, 60, 70, 80, 90, and if I go up to that 10th batch, 100. So you can see this fills out the table by going up by ones. A little easier to follow sometimes. You can see it matches up this table. 5, 75, 50. There it is right there. 7, 105, 70. Yep. And then the bottom one, 9, 35, 90. Yep. Matches perfect. So now I'm going to use those key numbers, which is the number of ounces for brown sugar and the number of ounces for white sugar, and I'm going to change those to pounds, and then I'm going to change that to number of bags. So a double conversion. So I take that first number for brown sugar, which is 150. So I know there's 150 ounces of brown sugar, so that's going to be my first number I write. So 150 ounces over 1, because that's just the whole number, 150 ounces, times my first conversion. I'm going to use 1 pound over 16 ounces. I want my ounce units on top and bottom of this fraction line to cancel away. So that's why I don't use 16 over 1. I use 1 pound over 16 ounces, which makes my ounce units cancel. And then I do one more conversion for the pound to bags. I use the conversion of 1 bag for every 5 pounds. So that last conversion is 1 bag for every 5 pounds, a double conversion here. So the reason I do this, I want all my units to cancel top and bottom ounces. I want the pound units to cancel top and bottom. All I want to see left is that bag unit. I'm asking for how many bags of brown sugar or white sugar should she buy. So if I set it up like this and then just time straight across, my ounce units will cancel, my pound units will cancel, and I'll be left with the unit bags which I want. So if I multiply straight across here, 15 times 1 times 1. So again, if I multiply this straight across, I will get 150 on top over 16 times 5, which gives me 80 on the bottom. So 150 over 80, if I divide that in my calculator, top number first divided by 80 second, I get 1.875 bags. Of course, you're not going to buy part of a bag. You're going to be forced to buy the nearest whole number rounded up. So 1.875 bags means I need to buy at least 2 bags to cover what I need. Don't want to buy 3 because that would be just a waste. Don't want to buy just 1, that would be not enough. So 2 will cover it. So now for the white sugar, I'm going to do the same but with 100. I'm going to change 100 to from ounces to pounds, and then I'm going to change it from pounds to number of bags. So if I use 100 ounces, and sorry, I'll go back. So 100 ounces over 1, because that's just the whole number. I'm going to use 2 conversions here. I want my ounce units on top and bottom, and then I want my pound units to cancel away too. So 100 ounces over 1, I use my first conversion of 1 pound over 16 ounces. That will make my ounce units cancel top and bottom times. Now my last conversion of 1 bag for every 5 pounds, that will make my pound units cancel and leave me with just bags. So ounces top and bottom, pounds top and bottom, leaves me only 1 unit left, bags, which I'm asking for. So now if I time straight across, 100 times 1 times 1 gives me 100. 1 times 16 times 5 on my calculator gives me 80. And if I divide 100 by 80, that gives me 1.25. And again, they're not going to let you buy part of a bag. You're going to have to round it up to the nearest whole number, so that would be 2. 2 bags would cover that. Okay, for the last problem, or second to last problem, I'm sorry, and I believe this is problem 8. The second to last problem, to prove to me that you're watching this, I want you to do a double conversion, but I'm going to change this number. The number I want you to do is 300. So I want you to find, if I had 300 ounces of brown sugar, 300, if I put 300 right here, what would I get? How many bags would I need to buy for 300 ounces? So that's number 8. All right, last problem is 16. And again, like I said, please, please, please do not think because this is the last problem that is the hardest. You can do all of these. So if you look at it, Don't be worried by these word problems. Just get out what you need. It's not as bad as it looks. So it's asking for a simple ratio. That first problem, easy ratio of how much blue paint to green paint. So it's asking for the first thing right away, blue paint to green paint. It's asking for 12 gallons of blue paint, 8 gallons of green paint. So again, it's asking for the ratio of blue paint to green paint to make aqua blue. So all I do is take that first number for blue paint, which is 12, and compare it to green paint, which is 8. So that gives me, if I set it up as a true ratio, 12 on top to the number of gallons for green paint, 8. And then I need to reduce that down. So if I take 12 over 8 and divide by the biggest number that goes into both without a fraction or a decimal, which would be 4, 12 divided by 4 gives me 3. And then 8 divided by 4 gives me 2. So that is the ratio. 3 gallons of blue to every 2 gallons of green will make aqua blue. So if you had 6 gallons of blue, you would need 4 gallons of green. If you had 15 gallons of blue, you would need 10 gallons of green. All right, next problem. All you're doing is finding 2 unit rates and comparing them. So dividing, and again, unit rates, always dollars on top. We would never have a unit rate with $1 on the bottom. So this store charges $140 for every 6 gallons, but again, always dollars on top, gallons on the bottom. If I use my calculator to divide that using the 140.4 first, and then divided by button, and then 6 second, I get $23.40 per gallon. For my next problem here, I need you to fix a mistake. So for store Y, again, I'm going to divide dollars per gallon. But just look at it real carefully. This is 150.547. That means I'm going to divide 150.5 by 7. I'm going to mistakenly write that as a 6 there, but I want you to fix it on your paper, fix it on a calculator. So here we go. My store Y, I'm going to do 150.5. So 150.5 divided by 7. So even though I'm writing a 6 here, I double check my math. I really did divide by 7. So again, please don't divide by 6 here. That should really be a 7. Change that on your paper. So 150.5 over 7 gallons. So 150.5 on my calculator divided by 7 equals 21.5. And you could see this one costs more per gallon than this one right here. So store Y has a much better value. $21.50 per gallon is a much better value than $23.40 per gallon. So that means store Y is a store you want to go to. It's cheaper by the gallon to buy paint at store Y. All right, the last problem here has you take the conversion unit rate number, or the unit rate number from store X, which is $23.40 for every gallon, and I'm going to times that by 14 gallons. So if I take that $23.40 per gallon and times that by 14, that will give me the last unit rate problem. So 23.4 over 1 gallon, because again, that is the unit rate for store X. $23.4 over 1 gallon times 14 gallons. And again, the gallon units cancel and leave me just dollars. So again, if I multiply straight across 23.4 times 14 with my calculator, that gives me $327.60. That's how much I'm going to spend for 14 gallons at that rate. All right, for the last problem on that paper, I believe this is problem 9. I could be mistaken, but for problem 9 or the very, very last problem, to prove to me that you were watching this, I want you to buy 14 gallons at store Y. I want you to use this conversion of 21.5 and times that by 14 gallons and show me those gallon units cancel away. So again, the last problem, buy 14 gallons at store Y's unit rate. So take 21.5 times 14 and show me the units. That will prove to me that you watch this. That will be the last big point assignment of the third quarter. Good luck.